Hey guys, welcome back. Mr. Will here. Video lesson for Tuesday, May 26, 2020 for the group. Every day I'm calculating. I hope that you had a nice and meaningful Memorial Day weekend, that you were able to spend it maybe outside with friends and maybe some family. Um, and I know if you were like me that you kind of need a little bit of a pep talk to kind of finish out the year strong. But we are so close. We have 4 days this week and 4 days next week to finish out the school year. I just would like to give you some words of encouragement to work hard, to focus, and to get all of your work complete and turned in to finish out the year strong. So we can do it. I'm here to help, and let's get to it. So today and the rest of this week, we're going to be talking about congruent shapes, angles, and sides. So first, you need to know what it means to be congruent. The word congruent means exactly equal in size and in shape. So you can have congruent segments. Segments are just part of a line, or a line actually, line segments. Two segments are congruent if they have the exact same length. Okay, they're the same length, they're congruent. Okay, two angles can be congruent if they have the exact same measurement. Um, and then you can have two polygons are congruent if all of the corresponding sides and shapes are congruent. Okay, so let's kind of take this word congruent, which means exactly the same in size and shape, and let's apply it to our problem today. Okay, we have Alexia is making right triangles to decorate the border of a poster. She traced around the triangle template of graph paper. Then she translated the template 5 units to the right and up 1 unit and traced it again. She labeled the original figure or pre-image triangle ABC and image triangle PQR. What is the relationship between the two shapes? Okay. First, we can look at this and we can say, okay, well, what line segments here would be equal? Okay. And what we can do is these are our points A, B, and C. So we can use these points of our triangle when we are describing them. Okay. And here we have points P, Q, and R. Okay, and we can use this. So for example, this line A and B, can you find the corresponding or congruent line in this triangle? Well, yes, it would be P and Q. So what you could do is you could write A, B, line AB is equal to P, Q. Okay, excellent. Okay. Another thing that you could say is they would be congruent. They have the same length. Okay. Good. Can you find any other congruent lengths? Yes, you're right. You could say line BC and lines QR. Okay. And you could just, when you list the corners or the points, when you're listing out the name. So you could say BC is equal to QR. Excellent. And there you have it. Those would be two equal sides. Now, lines AB, you could say measures 1, 2, 3 lengths of this graph. Okay, so it would be 3 boxes in our grid, so it would be 3. And lines BC could be 1, 2, 3, 4. Okay, would be the length of 4. In this case, it would be units. We don't know the measurement, but it would be units. Okay, so be 4 units. Excellent. Which segment in triangle PQR do you think has the same length of AC? So if we look over on this triangle, AC would be right here, AC. So this length here, what segment in this triangle would have that same length? Well, guess. It would be this one. It would be PR. So you list this point P and this point R. It would be AC is equal to PR. Excellent. Okay. So we are finding congruent lengths. When an angle is reflected, translated, or rotated, it is measured. Stays the same. Which angle in triangle PQR is the same measurement as angle B? Okay, so looking here, here is angle B right here. Okay, which angle in our congruent triangle would have that same angle? Yes, it would be right here, angle Q. And it looks to me like it would be a 90-degree angle. So angle B would be equal to angle C. Okay. Now, today we have talked about what it means to be congruent. We talked about congruent segments. We've talked about congruent angles. We've talked about congruent polygons. And then we've applied that to two figures here, triangle ABC and triangle PQR. And we have found similarities between the segments, between the angles, and between the triangles themselves. Today, what I would like you to do is apply what we talked about in our video lesson to your daily assignment today. If you have any questions, please let me know. I'm here to help. Today, it might be a good idea to start working on your problem of the week and your IXL lessons. These are the last. This is the last problem of the week for the entire school year. These are the last IXL lessons for the entire school year. They are due at the end of the day, Friday. So work hard. And once they're done, hey, that's it. You can throw yourself a little party. So work hard, ask questions, and I'll see you back here on Thursday. Thanks.